Hello, everyone, and welcome back to Beyond Compression, the podcast where we explore the ideas, technologies, and real world challenges shaping today's compressed air industry. Each episode brings you conversations with engineers, product experts, and industry professionals focused on improving reliability, efficiency, and performance across compressed air systems. I'm Pam, your host for today's episode. And today we're talking about something that's becoming a much bigger priority across manufacturing industries: oil-free compressed air. For many facilities, compressed air is more than just a utility. It directly impacts product quality, operational reliability, and even regulatory compliance. And joining me today is Matt, one of our product managers here at FS-Elliott. Matt, thanks for being here.
Thanks, Pam. I'm glad to be here. And honestly, this is a really important topic because compressed air quality often doesn't get much attention until something goes wrong. And when it does, the consequences can be expensive.
That's probably a good place to start. So, why are more facilities paying closer attention to compressed air quality?
A big reason is that compressed air touches far more processes than people even realize. And depending on the industry, compressed air may come into direct or indirect contact with products during manufacturing processes like product packaging, instrumentation, and automated equipment and filling lines. And when air quality becomes part of product quality, contamination risk becomes a serious issue. That's why industries like food and beverage, electronics, pharmaceuticals, plastics, and packaging facilities are increasingly evaluating oil-free compressed air systems.
And when we say oil-free, what does that mean? Because I think there's still confusion around that term.
There definitely is. So oil-free centrifugals still use lubricant for bearings and mechanical systems, but that lubrication system is isolated from the compressed air path. So the compressor itself does not introduce oil into the airstream during the compression process. That's different from many oil-lubricated compressors, like rotary screw, where oil is introduced during compression and then removed later using downstream filtration and separation equipment.
So instead of removing contamination afterward, oil-free compressors are preventing it from entering the airstream in the first place.
Yeah, it's more of a preventative approach. And that becomes especially important in applications where even trace oil carryover can create problems. Things like product contamination, increased filter loading, pressure drop, maintenance complications, condensate disposal issues, or even downtime from failed filtration components. A lot of facilities don't realize how many maintenance points exist in an oil-lubricated system until they start evaluating the total life cycle costs.
And that brings us to ISO 8573-1. What does that standard actually mean?
ISO 8573-1 is actually the internationally recognized compressed air quality standard. It classifies compressed air based on three major contaminants: particles, water, and oil. And each category has different purity classes depending on how clean the air needs to be. When people hear Class 0, they sometimes assume that means absolutely zero contamination across everything, but that's not really what the standard says. For oil content specifically, Class 0 means air quality more stringent than Class 1 based on limits specified by the equipment supplier or end user. For oil-free centrifugal compressors, the important part is that no oil is introduced into the compression chamber itself. That helps support the highest available air purity classification for oil content when the system is properly designed and maintained.
And I imagine that becomes especially important in industries where contamination could affect actual products.
Absolutely. In some industries, contamination isn't just a maintenance issue, but it can become a costly product quality issue. And honestly, that's where a lot of facilities begin rethinking their compressed air strategy.
That makes a lot of sense, because I think a lot of facilities probably don't realize how big of an issue compressed air quality can become until it starts impacting production or product quality. Have you seen customers run into situations where they discovered their compressed air setup just wasn't working for them anymore?
Yeah, one project that comes to mind involved a plastics molding and packaging facility that had been operating with several oil-flooded rotary screw compressors for years. As production expanded, the facility started paying much closer attention to their compressed air quality and the role it played throughout their operation. The compressed air supported molding equipment, automation systems, conveying, packaging operations, and several production-critical processes across the plant. But over time, the team became increasingly concerned about the risk of oil contamination affecting product consistency and creating unnecessary quality concerns. While their downstream filtration system was doing its job, they realized they were still relying heavily on filtration maintenance and separator performance to protect their process. And at a certain point, the facility decided they no longer wanted to manage contamination risk downstream. They wanted to avoid introducing compressor-generated oil into the compressed air stream in the first place. That's what led them to begin evaluating an oil-free centrifugal compressor.
So the priority really became protecting product quality and process reliability.
Here's where it gets even more interesting. So the facility wanted greater confidence in the consistency and cleanliness of their compressed air supporting production. And once they transitioned to oil-free centrifugal technology, they gained that peace of mind knowing the compressor itself was no longer introducing oil into their process. That helped support cleaner operation, greater process consistency, and reduce concern around contamination-related product issues or potential RMAs tied to product quality. But what was interesting is that the operational benefits extended far beyond just cleaner air. Because the facility reduced its dependence on heavy downstream filtration and simplified overall maintenance, they also saw significant reductions in maintenance complexity and operating costs. And by consolidating multiple compressors into a more efficient centrifugal system, they reduced overall energy consumption as well. In the end, the facility achieved more than $75,000 annually in maintenance savings, along with over $28,000 in annual energy savings across 4 plants. So while the project originally centered around improving air quality and reducing contamination risk, it ultimately delivered major reliability, maintenance, and efficiency improvements across the operation as well.
That's a great example, because it really shows how compressed air quality can impact much more than just the compressor room itself.
Yeah, exactly. That's honestly one of the biggest and most important takeaways. When facilities evaluate compressed air systems, they often focus heavily on initial purchase price. But the long-term costs associated with contamination risk, maintenance, downtime, energy consumption, and product quality can be far more significant over time. Oil-free compressed air isn't just about air purity, it's about protecting production.
And this applies across a lot of industries, not just plastics and packaging.
Yeah, definitely. We see strong interest in oil-free compressed air across many industries such as electronics manufacturing, pharmaceuticals, food and beverage, textile manufacturing, automotive, and packaging operations. Anywhere compressed air impacts sensitive products such as clean rooms, instrumentation, or production continuity, oil-free air becomes a really important consideration.
And beyond air quality, there are maintenance and reliability benefits too.
Yeah, there are a lot of benefits actually. Oil-free centrifugal compressors eliminate many of the consumables associated with oil-lubricated compression systems. That can mean fewer filters, reduced separator maintenance, less condensate treatment, lower service labor, and reduced maintenance downtime. And because centrifugal compressors use fewer wear contact compression surfaces than many positive displacement technologies, they're often selected for continuous duty applications where uptime is critical.
When a facility starts considering oil-free compressed air, what's the first thing they really need to think about?
The biggest thing is to evaluate the entire compressed air system, not just the compressor itself. That means looking at things like air quality requirements, flow demand and pressure needs, energy consumption, maintenance history and downtime costs, any product quality concerns, and of course any future expansion plans. When facilities take a full life cycle approach, they often realize oil-free compressed air provides value far beyond just cleaner air.
Matt, thanks again for joining us today and helping walk us through all of this.
Thanks, Pam. Glad to be here as always.
And to our listeners, thanks for tuning in to another episode of Beyond Compression, an FS-Elliott University podcast. If you'd like to learn more about ISO 8573-1 oil-free compressed air, or how compressed air quality can impact your facility, be sure to check out the resources linked in the show notes. And don't forget to follow FS-Elliott on LinkedIn and Facebook for future episodes, engineering insights, and updates from our team. Until next time, thanks for listening, and thanks for letting us be part of your journey towards smarter, more efficient, and more reliable compressed air systems.